Have fun.
All right, so our next example, just zero instructions, just an equation here. It says, hey, tell me all the things about this thing. And you're like, well, I wonder what this thing is. Let's see if it's a hyperbola. Okay, so the first thing we're going to do is we are going to group things logically. We're going to group all the x's and the y's together. And then we are going to complete the square as necessary so we can put it into the correct format. So grouping things logically, and remembering that I need to have a positive first term for my hyperbola, because it's not negative x squared plus y squared equals 1. It's always y squared minus x squared is the way we write them. So positive first term means I'm going to focus on putting this positive 4y first. So 4y squared minus 16y. Now we're going to group the x terms. Minus x squared minus 2x plus 11 equals to 0. Okay. You know what? I lied. I'm also going to, since I have the pleasure and ability to erase, I'm going to, let's kick this 11. Let's kick him over there. Just kind of getting ready to group the square. So I call this group logically. Get the number guy off to the right and combine the x's and the y's in the same groups with the positive one first. And so now it's going to be a big one. We're going to complete the square. Complete the square. And we went through that, how to do it in the ellipses section. So we're not going to totally review it, but we are going to do it. So y is green, x is blue. So we'll try and use some colors here. That'll hopefully help a little bit. All right, so first things first, I know that to complete the square, I need, we'll do the y version first. So the first thing we'll do is for the y, complete the square in the y direction. So first thing we have to do is get 1y squared. So to do that, we'll factor the 4 out of in front of the y squared term, and we'll factor the 4 out of 16 to get negative 4y, and we'll make room to add some number. What is that number going to be? Well, we'll figure that out in just a second, but we're just rewriting some stuff here. And if you add one number on the left, you have to add it on the right as well. And so, well, that number needs to be b over 2 squared, and b over 2 squared is b over 2 quantity squared. Well, our b is this negative 4. I'm very sorry, left-handed is not treating me well on this tablet today. Negative 4 over 2 quantity squared gives us negative 2 squared is 4. So we're going to add 4 inside here. But we're not really adding 4 to both sides, are we? Because it's within a parenthesis. So if we multiplied this out, we would actually be adding 4 times 4 is 16 to both sides. So make sure on the right you add the correct value of 16. Because on the left, you're adding 4 within the parenthesis, but to the overall left side, you're adding 16. Okay, so now what does this process give us? Well, it's allegedly from here on out, it should factor into a square. So let's see if it does. 4 times, well, what times what gives me y squared? Well, y times y. What times what gives me 4 and adds to 4? 2 and 2 come to mind. To get negative 4y, they both have to be negative, which gives us positive 4y, and positive 4 for the constant last term. And so we've got 4 times y minus 2, the quantity squared. That's starting to look like something we could possibly work with here. Now let's do the x guy. And for this, we have to make sure that we have 1, a positive 1 in front of my x term. So we are going to factor out a negative 1, and that gives us x squared. Negative 1 taken away from negative 2 gives us positive 2. Positive 2x, and think in reverse. Negative 1 times positive 2 will give us the negative 2x that we're after in reverse. Okay, make room to add some number to both sides. We'll figure that out in a minute. So we get negative 11 plus blank plus blank. We'll figure that out and simplify as we go there. Okay, so, no, that's needlessly complex. Let's just write that. Let's simplify this. No, it's not. It's fine. Negative 11 plus 16 gives us that this thing turns into 5. So we'll start with 5 plus whatever number. So what are we going to do here? We're completing the square on the x. So b over 2 squared here is equal to 2 over 2 squared, which is 1. So we're going to add 1. And what are we actually adding here? And again, you got to be really careful with what you're actually adding. What we're actually adding here is -1 times +1 means we're actually subtracting 1 on both sides. So this guy is actually a -1 in disguise to the overall left-hand side. So it's got to be a -1 over here. And the parentheses aren't totally necessary, but it just makes it more correct. We don't like to have two signs together without a parenthesis between them. So what did that do for us? Well, allegedly that made it so things factored nicely. So let's see. 4 times y minus 2 squared minus, I'm just going to change that -1 into a minus. And what does this factor as? Well, x times x gives me x squared, and multiplies to 1 and adds to 2. 1 and 1 come to mind. +1 in both places gives us a +2x and a +1 as desired. So looks like we've done it. The right-hand side tidies up to 4. Okay, so this, now we've completed the square twice, once for the y terms and once for the x terms, to get 4 times the quantity y minus 2 squared minus the quantity x plus 1 squared equals 4. And so now we ask ourselves, all right, so we finished completing the square. And so now we ask ourselves, well, what does the equation of a hyperbola look like? Well, it looks like x squared minus y squared equals 1, or y squared minus x squared equals 1. So what do we need to do to make this thing equal to 1? Well, we need to focus on the right-hand side and say, okay, well, to get it equal to 1, we'll divide the right-hand side by 4. And if you divide one hand side by 4, you have to divide everything on the other side by 4. And that leads you to the expression y minus 2 quantity, or the quantity y minus 2 squared minus the quantity x plus 1 squared over 4 equals to 1. And we now have done it. We've put this relatively ugly-looking expression into the correct format for the equation of a hyperbola. So let's keep looking at this example. All right, so I'm going to have to rewrite that onto this slide. So y minus 2 quantity squared plus minus x plus 1 minus quantity x plus 1 squared over 4 equals 1. And from this, we can identify some things. We can identify that b is equal to 1. We're playing the same game we have been. And a is 4 squared. 4 is a squared, so a is equal to 2. And then we can use that information to draw ourselves a Pythagorean theorem, a right triangle here, and find that missing c value. And so c is equal to the square root of 2 squared plus 1 squared. It's root 5 again. Again, by now we've got that memorized that that's approximated by 2.2. Okay, so what can we do now? First things first, we know that this thing, since y is never, we can't not have a y term. We know that this thing opens vertically, so that's helpful. And we'll give ourselves a set of, axes here. Oh, no. Focus. There's an order to this. What should we identify first? Well, in order to do this, the rest of these we've been provided with the center. It was either at the origin or it was a provided point. Here it's HK, where the H and the K are y minus K, respectively, minus x minus h quantity squared equals 1 over b squared for y and a squared for x. Okay, so what is our y value? The y value is equal to, and be careful with your signs here, it's equal to 2. And the x value is equal to, looking over here to the left, how do you write x plus 1 as x minus something? X minus a -1. So x is equal to -1. So our center is at -1, 2. By identifying that first, that gives us a nice anchored starting point. So let's give ourselves, again, I'm going to cheat here, but graph paper is very useful. I'm going to scale our axes correctly. So 2 in the negative y direction, and 1, 2, 3, 4, 5, 6 in the positive y direction. And then 6 in the negative x direction, 1, 2, 3, 4, 5, 6, and then 1, 2, 3 in the positive x direction. Okay, so our center is at -1, +2. So here we are. There's our nice big center starting point. And so the next thing we could do is we know this thing opens vertically because our y term is first, so we know it opens something like that. So our transverse axis. So let's put step 2, the next thing to draw is our axes, and then generate our box. Okay, so well, our transverse axis, since it opens vertically, is this vertical axis. So let's just go ahead and label that. That's x equals 1, a useful piece of, x equals -1, excuse me, a useful piece of information there. Now you could, if you wanted to, draw in this kind of other axis. It just kind of helps us as we're counting left and right the correct values here. Okay, so we need to go 1 in the vertical direction because b is equal to 1. So from our center, we travel 1 up. I'm sorry, that should be green. 1 up and 1 down. And we label these things vertices because they are vertices, so we don't lose track. And then let's see what else. Let's just, since we're going vertical, let's do our focus, our distance from the center to the focus. And that's 2.2 away from the center. So starting at the center and moving 2.2 up is going to be just a hair above the 1, 2, 3, 4 line. Starting at the center and going down, 1, 2 is just a hair below the x-axis. Now these are foci, so let's label them that way. And let's see, next but not least is our a direction. The x direction is 2, so starting at the center and traveling 2 to the right, starting at the center and traveling 2 to the left. And that's where labeling that kind of secondary axis, which doesn't have a name and it's not important, can be kind of helpful when you're drawing these things. But on graph paper, that really isn't a problem. Now we can generate our box. And then when you generate your box, you may as well generate your asymptotes. And from the look of things here, while this thing is vertical, it's going to be a fairly wide vertical guy. Oh, I could do better than that. And it definitely goes through the vertex. I'm just trying not to obscure the vertex point. Okay, so we've got that. So what was the process? I did a poor job of writing the process down. It was the center and then the axis in the box. And the next thing, you do the vertices and then the foci. And then from there, you could do your asymptotes. And then you have enough to draw the graph. It's really the same process we have been doing, but just not centered at the origin. We could take the time to list out all the things we know. Well, we already wrote the center, so I'm just going to kind of quote that and then continue our list. Our vertices, here we just have to look at the graph, and by drawing an accurate graph, you can really help yourself. So our vertices are at, the lower one is at -1, I'm sorry, the upper one is at -1, 3, and the lower one is at -1, 1. Our foci, in this case, are going to be, all right, so they're a little bit different. So -1, we start at our center in the y direction of 2, and we travel up √5, so we've got 2 plus √5. And then for the second foci, we have -1. Excuse me, a sneeze snuck up out of nowhere. We have -1, and then we start for the y coordinate, we start at 2, and then we go down √5. So we subtract √5 from that to get to the exact value of those coordinates. We already labeled the transverse axis here. Our transverse axis should be x is equal to -1. And then trans axis, x is equal to -1. And last but not least, we have some asymptotes to figure out. And so, again, counting slope as rise over run. Well, from the center, you would rise 1 in the b direction, in the x direction, and then you would run 2 in the you'd rise 1 in the y direction, run 2 in the x direction, so you'd get your slopes are going to be positive and negative 1/2 respectively. And so what point are we going to use? Our point is going to be our center, because both asymptotes necessarily go through the center of -1, 2. And so for the kind of increasing one, which I've been calling L1, so L1 over here, L2 over there. For the increasing one, you would have y minus 2 is equal to positive 1/2 times x minus the -1, which is y minus 2 equals 1/2 times x plus 1. And then L2 would be y minus 2 times -1/2 times x minus the -1, which is x plus 1. And I leave it to you to algebra those out. But that's good enough for this example.